the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Stevens Institute of Technology is proud to present the Hugo New Corporation Sustainability Seminar Series, co-sponsored by St Consultants, H2M Architect Engineers, Brown & Codwell, and BEM Systems.
Thank you, everybody. So I'm going to just go through, explain to you how the industry works from a climate change resiliency standpoint. Going to give you an overview on how a policy is set at the governor level, how the regulations are drafted, how they are promulgated, and how the industry uses them, and then how you actually build the assets or protect the assets from flooding. And at the end, I'm going to also give you a little bit of overview on the environmental industry. How big is it? As you guys graduate, I just wanted to give you how big the industry is on an annual basis, how much business it does, what are the options you have from a job standpoint, what's the increase, as the Department of Labor publishes the data of how many jobs would be available in this field, what is the average income during the 30 or 40 years of a lifespan of a working career. So that may help you to give you a little bit of a guidance on how the industry, how as you look for a job, what to focus on, and what are the different fields or different locations you can work on. So I thought that may be a useful tool for you. And as you graduate, some of the things that you should focus on, where being in the industry, what the future is going to look like. So may just give you some pointers on that. So with that, okay, how does it? Yeah. Oh, shouldn't you just? Oh, I don't have to use this. Oh, no, it's. I just do up and down.
No, next. Yeah.
Next, okay. So what I'm going to talk about is, even though a lot of you guys are doing sustainability or environmental engineering, one of the things that is closely associated with sustainability is resiliency and also adaptation to the climate change. So, so that's a very important, subset, or it's a bucket of sustainability that, they go tie in together. So I was going to talk about that. Quickly, has anybody taken a class on climate change, global warming kind of thing? One person I see. Couple of them over here. Yes, I would recommend, if there's the availability, you please do take a class in that field, because that's going to become more prominent 20 years down the road when you'll be in a peak of your career. So the way I'm going to show you is how at a governor's level, how a policy is set, and then how the rules are promulgated and how they go through and making it make it as a regulation that everybody has to follow. So New Jersey being, this is just right off the press from Monday. So governor generally signs the executive order telling all the agencies or everybody in the state that this is what the state's going to state's going to focus on. So this is just from Monday. We had a press release for the Energy Master Plan for the New Jersey, where they want to we want New Jersey to become clean, 100% clean energy by 2050. So we are not using anything from coal, natural gas, or from any other. It can be either offshore wind, solar, nuclear, that kind of thing. So as part of that, he published this EO 100. What it basically says is, it says to NJDEP, which, as you know, is the regulatory agency that governs on environmental, environmental in the state, for them to establish PAC, Protection Against Climate Threat Regulations, in 2 years, which will be January 2022. So what it would create is, as they draft those regulations, they're going to anybody doing a project in coastal areas, or whenever you get impacted by climate change, you're going to have to follow those regulations. This would be similar to you applying for a land use permit. If you are doing a development like Stevens on the Hudson River, you have to get a waterfront development permit now if you are in a river, or you have to get an Army Corps, U.S. Army Corps of Engineers permit. So it would be regulations that would be published over the 2 years, where sea level rise and climate change would become integral part of any development in the coastal area. This is a big deal for a state like us, who has, we have how much, 1,700 miles of coastal coastline in the state. So it's and we are a coastal state. The number one revenue for the state is from going down the shore. We have 130 miles of beaches in the state, so it's a big business for, as a state, it's a big revenue generator for the economy. So now what it's saying is, any development on the coast, or you're going to have to comply, integrate sea level rise into regulatory and permitting process. So this is what governor had set the focus for the state. Similarly, he has there was another EO in October of 2019, where it was directed to NJDEP to establish a statewide climate change resilience strategy. Means they wanted the state to develop, I think the deadline is September of 2020 this year, to develop a approach on how the state is going to protect from storm surge, sea level rise, wind. It's mostly from hurricanes. The frequency of hurricanes is going to get more. Temperature, as you can see, we are getting less and less snow. If you look at the data, we're getting less snow every year, and probably in 20 years the weather over here would be more like North Carolina than than what we used to get 20 years ago with the snow. And the precipitation, you can see rain, the number of rain is the amount of inches of rain we are getting annually is going up every year over the so that is what this year was. So all this tie into, I'm going to just so the way the regulation is drafted is going back on that PACT regulations is DEP puts out a draft regulations for a public comment, and then all the public and everybody can comment it, and they addresses those comments. They go through a rule changing, and then they publish the final rule that are promulgated that everybody has to follow. So the rule, it's not government agency can go in a back room and just put the regulations out in the street. You have to go through a public comment period, and there is like thousands of comments, people comment, and then they have to go through everything. Developers would say, oh, we don't want all this to be incorporated, but the environmental groups would say, oh, you're not stringent enough. So there will be a lot of back and forth. We also don't want to kill the economy, so there's a lot of fine balancing you have to do as you promulgate new regulations, especially something like sea level rise. You had a question?
I do. Is there a requirement for them to actually listen to the public comments?
Yeah, they do
listen,
have.
But I mean to act on. I should have said to act on public comments.
Yeah, yes. So they'll have a public comment period. They'll have a session like this where people can come in, and they'll have a mic and you can speak, and then that comments get recorded and they address it. Now,
I'm thinking, for example, federal programs, there are all these changes being proposed and have been proposed the last few years, and there are public comment periods, and then they go ahead and do what they want anyway.
they have a lot of leeway, because some of the people would say, oh, don't allow any development, and then they're going to say, yeah, we hear you, but we still have to generate tax revenue kind of thing. So a lot of them gets addressed, but some of them may not, because they have to find a middle ground on everything.
But there is no guideline. They have the flexibility to
Yeah,
listen as they choose.
yeah, there's a little bit of flexibility. You're right with that. So that's similarly, there was a report that came out in December by Rutgers and NJDEP about what they are seeing as a sea level rise projection. As you can see, the report says the 2030 and 2050 numbers are already baked in, means the sea level rise for sure is going to be around between 0.5 to 1.1 feet or 0.9 to 2.1 feet in New Jersey. It's now forward looking is where they have given you, low, moderate or high based on, how the global warming goes. So that is what, so this is a good indicator. Now this report would become a basis of any resiliency regulations or even that PEC regulations coming out. So this, if you don't have it, you can Google this thing report, all of this EOs or anything, you can Google it and you can review it. It's a good way, forward looking projection of what we see the state would face, all the way till 2150. Similar to New York City, across the street, they have their own New York City panel on climate change. They had published the report in 15 and updated in 2019. They look at around 100 miles around the city. So all this area, northern New Jersey, gets covered. They are projecting the similar type of increase in the sea level rise, and you can see the precipitation increasing by 15%, 19%. So if you are increasing rain by 15%, definitely you're going to see an inverse of less snow. And the numbers are a little bit inches wise off. This is also a continuously evolving science, so it's not like set in stone. Every 4-year IPCC, you guys may all know that they publish the whole global report for the climate change, and every 4 or 5 years things gets updated. So everybody has to, and the photograph I have this is the damage. I don't know if anybody has taken the train at Hoboken. This is what it got damaged at Sandy. So some of the photos you'll be seeing is around from a Sandy. Similar to, what I wanted to cover is from a transportation standpoint, from trains, buses, bridges, how obviously we have a federal government that is not keen on climate change right now, but this is from previous couple of administrations. So they would still publish research documents or reports that they, similar conclusion, that they are saying very likely that the rain is going to increase by 90%. But if you look at the sea level, they are virtually certain, 99%, that we're going to have a sea level rise that's going to affect transportation infrastructure, from the tunnels to bridges to any other thing. Same with the hurricane and the heat days. We'll see more more like another report that was published, FHWA. So there's a US DOT, who is the Department of Transportation, that oversees all the infrastructure. Underneath there is a FTA, manages the rail, like New Jersey Transit, that is Federal Highway Administration, which oversees or funds the roads and bridges. They are, their report also said the same thing, that you need to account for climate change as you design projects. So you have to identify what is your critical assets, and you have to find out, you have to calculate or establish what is going to be the vulnerability of that asset. You can be vulnerable to coastal flooding, sea level rise, temperature, wind, precipitation, those 4 or 5 criteria. So I'm going to just give you an example on how in an industry you would protect against something, where you have a coastal flooding or a storm surge, similar to we had in Hoboken during the Sandy program, and how an agency like New Jersey Transit is adapting and how making their assets resilient after climate change. So the resilience analysis is very simple. You identify what is your critical assets, and then you say, are they vulnerable to climate change? or extreme weather events. And then you can establish, you're basically calculating, you can create a different scoring system. Everybody has different ways to calculate it, but you're calculating what is the risk based on the criticality and vulnerability of the asset. And then you create scoring for that, and then you say, yes, I have to protect this asset, and then you make it as a capital project or operation project to protect that asset. So the criticality, when someone like a transportation agency looks for a criticality, they look at, okay, how many people are driving this road, or how many people are taking the train, are there options for the passengers? So like if you look at a Hoboken, if we can't bring people in, they can't take PATH or the ferry to go to New York City. So the whole system gets, or people coming into the bus. So only option would be people coming to the bus and then taking PATH or ferry. So you account for dependent role of emergency. Someone like if Hoboken terminal, it's a for anything from a emergency purposes. If we need to move people from lower Manhattan or from Manhattan, especially folks commuting to New Jersey, we need that line open from a ferry and the PATH standpoint. And then if we bring 50,000 people over here, we need an option to move them out, from the ferry and the bus, ferry and the PATH. So you account for the role. Does it have a redundancy? Are there any other options? So like you can say for a Hoboken, yes, so we have, if the train doesn't work, we at least have a bus system that we can bring in just more buses, and transit has done that in the past. Time to repair, how long it's going to take repair, or how much it's going to cost. Similar to criticality, and you can establish a score of, you say, 1, 2, 3, we're going to range, we're going to calculate all of this, and then you establish the scoring system. I'm not going into all that detail because everybody can, establish their own scoring, but I'm just giving you a criteria that how you should evaluate. Vulnerability is, now you look at it, okay, how is my asset vulnerable to extreme weathers? And so what is the exposure? How often we think we're going to get storms, or what's the flood elevation over at Hoboken? Is it at the mean sea level, and how often does it flood? Or how we going to adapt? How we going to adapt to that? Are we going to have some seawall built? Like some folks, you may know, there's a rebuild by design project ongoing in this area, which was after Sandy to the Hoboken, except Stevens, everything flooded because, in this area. So now there's a whole project going on, almost of $400 million of rebuild by design to build flood. I think it's basically flood walls or something, right? Flood walls to protect the whole area. Gates, and the gates are going on Hoboken. So that's why you do the vulnerability assessment to say, to calculate, and you can do a similar 1, 2, people have to do different scoring, 1, 2, 3, 1, 2, 6, and then you add up all the score and say, okay, seems like, this is a high, medium, low of my assets. If things get high scoring on resiliency, you say, okay, I really got to do something. Lower scoring, you may say, okay, we have time, we can wait and evaluate every couple of years and see as the new data comes in to see if, we got to really do some, we got to protect the asset. So this is another, I wanted to just share with you. This was the actual flooding that happened on Sandy. So, for New Jersey Transit. So you can see this is actual 5 feet of water where the ferry terminal was, 5 feet where the tracks are. So on the low location of the certain areas, you got, 3 feet or something. Oh yeah, it won't show because it's the thing. So you can see this is just wanted to, this was a calculation as we had done based on the actual data we had got post Sandy storm, and this is I think the day of the storm, the October, whatever, the 31st, 2012. So I'm going to now pivot to how an agency like New Jersey Transit protects their asset. So, Sandy came in, there a lot of damage, they got federal money, so they are doing, bunch of projects in Hoboken. how to, to make sure that they don't flood again. Because from a federal government standpoint, they don't want to give you money for the same thing again and again. They'll be like, hey, you guys, even though folks may not believe in climate change in the federal level, but when the funding comes, it comes with some strings attached. So you can't call climate change, but it's a different color. So I'm going to go through a couple of projects, just give you an example on how New Jersey Transit. What happened? It skipped. Yeah, it was over here. Okay. So this is how New Jersey Transit after Sandy manages it. So they developed their design criteria to say FEMA is the federal emergency management agency. They publishes the flood maps for the whole country. So then, you use that. They generally publish it for either a 100-year storm or a 500-year. In certain areas, maybe if you're low-lying, it would be in a 500-year. 100-year storm is a 1% chance of happening, in 100 years. And 500-year event would be, 500-year elevation would be 0.2%. So what New Jersey Transit does is they establish this criteria of 2.5 feet for coastal and 1.2, I think it's 1.5 actually, there's a typo. 2.4, it includes a sea level rise. Most of the assets are only lifespan of 40 years, so you don't go all the way to increasing to sea level rise to 2080, because you're only looking to raise it for 40 years, so it's like 2060. So you only assume sea level rise calculation up till that what would be by 2060, what will be the asset life. So that's why it's 2.5 based on that. So this becomes the basis. Anything agency like New Jersey Transport Authority, there's a BFE plus 3. If you go across on the town, in MTA, they have a similar type of number. I think it's BFE plus 3. So they'll have this criteria that they would use, as they design projects. There was also executive order in 2015, which was rescinded, which was canceled by the new administration, but it included multiple additional analysis beyond just using the FEMA. So they recommended a freeboard approach where, say, if you have a critical asset, you should just assume to raise it by 3 feet, or you can look at a 500-year elevation, and there are insurance companies publish this flood insurance data, so you can use that. And you can calculate from there what would be your elevation for 500 years. And then on a science-based approach, Army Corps has a sea level rise calculator that you can use and say, okay, I'm located over here. What would be my sea level rise in 2060? And they give you a low, medium, high, criteria to pick. Or even I think there's a intermediate high. So a lot of the time you use an intermediate high to add in for the sea level rise for the climate science. Rutgers has published a local for New Jersey, a similar type of tool for sea level rise. And obviously with this whole, what I covered earlier, with the new regulations coming out, they would have a statewide approach or a tool available online that people can use, plug in their address and say, okay, what I need to protect my house against. So similar, even though this has been rescinded, new agencies would be like New Jersey Transit would be still proactive and say we're going to still follow this, follow this executive order from Obama administration. Oh, I keep on going to the wrong. So I'll give you an example. So this is right inside the terminal. There's a boiler. You can see that's the green boiler, and it's an elevation. You can see its elevation is in 10.5. Anybody knows Hoboken? Hoboken's mean sea level is 4, so it floods very often with just a little bit of high tide coming up. In the Hudson River, especially the plaza outside of the terminal and the ferry area, including the tracks. So asset elevation is 10.5. So when you look at the FEMA BFE for Hudson County, there's a GIS tool published by FEMA county by county that you can, it's basically, it tells you where you are, what's the elevation. So that's 12 feet. Earlier we said for New Jersey Transit, they would say we're going to add in 2.5 for any coastal assets to the FEMA BFE, so it's 14.5. The climate science approach, looking at the sea level rise calculator, was calculated as 13.8. The free board said add in, if this is a non-critical asset, it's just a boiler, if there is no heat when a storm is coming, it's fine, we can survive as long as the trains are running. So that's why they used it as a non-critical asset. So that's why the calculation is 4 feet. And when you look at the 500-year storm event, which happens 1 in 500 years, the elevation was 14.3. So what New Jersey Transit would do is we pick the worst case of all the 4 calculations, and we'll say the recommended elevation has to be 14.5. Now, someone like this, we can't raise it. If it's at 10.5, we have to raise it by 3.5 feet. We can't raise the whole boiler up. So then the designers say, okay, what are the other options? Where is the water going to get in? Can we make those areas water, seal them? So that's what the design option they would select is, let's just create a, on the picture on the right, you can see it's, let's just build a watertight entrance door that if a storm is coming, we can close it and block it, and even the outside would flood, the water would not get in. So that is how, people would operate, the designers would find options to work. It's not everything can be raised up and protected. Similar to this, all over the Hoboken yard, you can see there are all these transformers. Their elevation, you can see it's already at between somewhere from 6 to 10 feet. So it's already, way, and we need to get it to 14.5 feet. So a lot of the time, so the designers would say, that we have a catenary running, we'll just move all of this at a higher elevation, and you can see they'll design it and say we'll put it on the poles, existing poles, or install new poles and raise them. So that even though the Hoboken is flooded, in future, if that 5 feet water we saw during Sandy, let it flood, we can shut down our electric supply, but after the storm is gone, we can quickly get back and running the trains. This is another term, you can't see the design over here, but this one was a substation, and this is the design. You can see a lot of the times they'll just build a structure and say we're going to just raise it to get to 4.5 feet and let people take steps to do the maintenance of the substation. I have a better picture down further. And you can see it's the same calculation you are doing for every asset. Some things change, some doesn't. So this is one of the, I think you can see it from the, what's the street? You can see it from the road, this building. This is one of the archaeological SHPO building. So they are changing one of this observer highway substation, and you can see on the design on the right, they are basically raising it. They'll do piles and build a foundation and raise up the whole thing, as if, when you see down the shore, the houses that are elevated. Another thing is they have so many assets all over the Hoboken Yard. Hoboken Yard is 50 acres, so there are a lot of assets that, there is potential to flood. So then that's all they'll say, okay, what we can move, on the poles, can we eliminate some of them to make sure, or can we create underground waterproof trench, conduits that we don't have to worry outside can flood, but the water would not get in. So they'll have, you can see all the existing projects going on that they are raising it from 6 to 10 to 14.5. This you can see, this is another way. This is a train wash area. It's on the other side where the Newport development is. You can see the door. So the door has all the electronics on how they, to operate the train wash, and it needs to be raised to 14.5. So the another option they would do is like, let's just raise the whole door up, and you can see on the picture. So they'll build the steps, reconfigure the door entrance, and then inside you go down again in the steps to get down, kind of thing. But at least your asset is now protected. This you can see it from the street as you are going, going towards the terminal. This Henderson Substation, there's construction ongoing. This was all damaged during Sandy, and you can see the design. the way they are doing it is they're basically making a first floor as just a, you know, just an entrance, and they'll have a, like how we have in the basement vents, or the windows, they'll open up windows like those, that if the storm is coming, they can just open up those windows and let the water run. But the whole asset is elevated at that 13.5. This is on the all the way on the other side. I think it's Observer Highway or so, or no, Marine Boulevard. They are on that side. So, you know, they'll raise it to 13.5. The construction is ongoing right now. So all the all the substation, you know, everything would be elevated, and you can see all the you know, all the transformers inside for the substation would be elevated at a higher elevation, and the basement would be, they have to just go in during the storm, open up the windows and say, okay, let the water run inside and out. So another thing Transit has done, we had worked on this with Stevens at Davidson Lab. They had also built some emergency warning system when a storm is coming to notify and protect their assets. We had worked with Stevens on a project a couple of years ago of building an emergency warning system. So you absorb across the river from the battery and from other locations the hydrograph, which is for 84 hours before they tell you how much water you're going to get. You ingest it and you tie that to the critical assets, because you already know the elevation of them, and say, okay, now this, you know, the red is, that's what the thing is, the red is when a storm is coming. This is just an example of where, you know, the red is anything in that area would be flooding, yellow has a potential to flood, and green is protected. So, you know, when a storm is coming, this is a warning system right now New Jersey Transit uses in real time, because they can't shut down the whole train system in one day because of the commuter folks like you know, using the system during, you know, you want to, from Stevens, you want to go to home or something, so they have to curtail the service. So to curtail the service, that's why those green and yellow areas are. They can say, we're going to have a couple of tracks open, but we're going to close this thing out because this thing's going to flood before. And a lot of the equipments they have at Hoboken are analog. They have big switches from 100 years old that there are no parts available. All the companies are gone, so they handmade those parts. So they have to remove those switches when a storm is coming, which they have to get a truck. It's like a refrigerator. They lift it, put it on a truck, and move it. And it's a huge expense for them to change all that old historic stuff and make it digital, you know, make it as a digital. It's hundreds of millions of dollars, so they're doing it in stages. So they'll say, okay, we still got to use those old, they have almost 100 switches. So, you know, I think there may be a dot, so, you know, I don't see a dots, but you can see we have, when the system is operational, all the switches are mapped out. So we'll tell them as the storm is coming, focus on this switches first because this may flood, or we are good on this thing. And if the storm intensifies, you remove more. If the storm moves away, you know, moves more further west, then you say, okay, we can, you know, you can start installing the switches back, or we don't have to remove them. So this is what I think I had just overall. I know I covered a lot of stuff with you, but just giving you a real-time solutions. You know, it's not a one solution that, oh, we're going to just move everything inland, or we're going to raise everything. Everything you have to look from engineering, look at from operations. There are multiple ways you have to look at cost to replace. And then you have to make a decision, what is the cost-effective way to protect it, because there's never going to be enough money to protect everything against, you know, incoming storm or, you know, climate change. I'm going to now pivot and give you just a little bit of example as you guys graduate on what's the environmental industry, how big it is, what are the opportunities you may have for jobs, things like that. So this is the job, Department of Labor publishes the data. So, you know, they'll say this is a little bit outdated, you know, a couple of years old, but if you go to US Bureau of Labor Statistics and you can do a search, and say, oh, I want to see what's the environmental market is about. So what it's saying is over a span of your career, the average salary is around $86,000. In 2016, there were 53,000 jobs available in the country in this field, and it was 8% higher than the average. So that gives you indication of is that market good or not, kind of, and they project it, every year it gets updated. So as you grow, this would be a good way for you guys to understand, to see, okay, is the potential of them, and you can search about anything from sustainability to any, it's a good way to understand what the market is. So something you should be aware of. This is what the so what are the different segments? So you guys are studying sustainability, but the energy conservation, green buildings, the sea level resiliency, I think those are going to be in future, main fields in the industry. Like the hazardous waste, at one point when all the cars are becoming electric, it's all the gas stations and everything would be gone, and it's going to happen in your lifetime. So that hazardous waste and all is going to be gone to a certain. You'll still have wastewater treatment, water supply, air pollution, but this gives you all the different market segment. These are the different fields you can join in the industry, and you can, if a company does multiple of them, you can learn all the different different segments. What are the type of clients? If you are looking for a job, you can work for engineering firms like what we do. You can work for big industries, refineries, people manufacturing stuff, pharmaceutical. You can work for government agencies like NJDEP, agencies like Port Authority, Transportation, or New Jersey Transit. They all have environmental groups, environmental. So you can work for them. You can work for federal. Every federal agency has an environmental need. So so you can. These are the private is the biggest job market, private sector. Most of the jobs are in the private sector. You can work in different locations, but the consulting, environmental engineering firm, that's the biggest field. Government doesn't, everybody would say, oh, we want to just hire professionals to get things done. So that's a big field for you to, and that's where the opportunity is for the growth too. But this just gives you a type of, climate, clients that is, as you guys graduate and apply, just think about that, okay, where do I see myself in 20 years kind of thing. And academic is another, I didn't list it, but it's another field. This is what the overall business is. If you look at it overall, this is in, I think, millions of dollars, but you can see right now hazardous waste is the biggest market. Water supply, which is the drinking water, wastewater is the, wastewater treatment plants, environmental science and other. But I think this field, this 20 years when you guys are, become in the peak of your career in your 40s, this is going to look different. I think climate change and sustainability and all that, that's going to be a bigger part of the business. It's all right now put into other, but I can see that it's going to be, there's going to be a separate bar just for that space. And the overall, I think I didn't list it, but I have a graphic that I'll send it to. Overall, I think the market is around $30 billion annually, so that you get the idea. It's a huge, it's a good market. It's a huge market from a, from a long-term job standpoint. This is, it's a 16 billion. Yeah, so in 2017, the market was $16 billion. So you can see the hazardous waste is still the big, but natural resources is picking up. Sustainability is 2% of the market. So this gives you idea as you guys, look for jobs, that, to see what you need to, depending on your aptitude or what I want to focus my career on. This may help you to, decide on where to apply and how to look for jobs. And a couple of thoughts I'll give you is, if you are doing engineering, pass your EIT before you graduate. I think it's going to give you advantage in the industry, so that by 3 years or 4 years experience, you can go for a PE. Having that credentials, would be good. A lot of the times, if you're going to work for a consulting firm, even though you may want to do sustainability, they may ask you initially to say, hey, you may have to do a hazmat work. So it's good to get a 40-hour HAZWOPER certification. A lot of them are available online I think it's a good selling point. I advise everybody to just have it, even if you're never going to do hazmat work. Once you do it, it's always going to be on your resume, which is a good thing. If even to your sustainability, eventually everything we have to manage is manage a project. Client hires us if you're going to do consulting side. So even if there are project management classes available, not in your field, I would recommend take a couple of them or at least one. Same with the GIS, know the basic GIS, as React GIS, how to, and when you guys are going to be 10 years, 15 years in the industry, this whole data analysis and statistics is going to be a big thing, because all this climate change data are going to come in, and people's going to be, there's going to be a lot of data to be analyzed. So ability to understand that, doing a basic programming, Python scripting or something like that would go long, for your long term, for your long term career. So just couple of, as you graduate, if you're applying for a job, if you have a couple of things in here that would always be, catch reviewers' attention. They're going to say, yep, oh, we want to hire folks with, this type of capabilities. There are also other certifications like CHMM you can get, you can get lead AP kind of thing. I don't know if they are allowing for masters and all in the sustainability to that. That's something to, to do that. I think all that would help you having, if you walk in for a job, and a lot of you are doing masters. So, for you to make your resume, because this initially when you get hired, it would be a undergrad can do what you guys are doing if you don't have experience. So for you to say, oh, I need to, you need to give me more salary because I have a master's, you need to really differentiate, with the classes you take, with the studies or the projects you have done, internship you have done, plus, things like this may help you to get a better, starting salary. So, and with that, questions?
All right.
Thanks.